Objective 3 says know how to calculate the atomic mass for an atom given the isotope's mass and percent abundance. And I actually asked two questions about this data. I said, what's the atomic mass and what element is it? Because once you know the average atomic mass, that is on the periodic table, so we can identify an element by its atomic mass. We can't identify it by mass number because some elements have duplicate mass numbers. They have isotopes with the same mass number. But average atomic mass will be different for every element, and so we can go ahead and identify it. So go ahead and take a minute and see if you can calculate this. And while you're doing that, I'm going to freeze my frame up here and type in my solution. And remember, there's multiple ways to do this. So if you do yours differently than I do it, but you get the same answer, that's just fine. So here's my solution. Let me just find my little remote. There you go. So I like to do it. I take the 85.5% times 32.015. I don't bother moving the decimal because I would have to move it for all 3%. And A, I'm lazy, and B, I make dumb mistakes. So if I have fewer steps, I have fewer chances to goof up. And if I have fewer steps, I have fewer steps, which I like. So I just type in right like it says, 85.5 times the 32.015 plus 10.2 times the 33.016 plus the 4.3 times 34.08. Because what that percent's really telling me is that 85.5 elements out or atoms out of 100 weigh 32.015. Just like if we were averaging the weight in here and 3 people in here all weighed 120 pounds, we'd take 3 times 120. So that's what we do with our average here. 10.2 out of 100 weigh 33.016, so I go ahead and multiply them. 4.3 out of 100 weigh 34.08. And then when I get done with that, I have to divide by how many atoms I had. I had 100 or 100%. So I never hit the percent key. I never move the decimal. I just pluck it all in and let my calculator do the work. The other thing is use some number sense. If your lowest mass is 32 and your highest mass is 34, your average has to be somewhere between those two. If you get 0.32 or 3.2 or 320, you've got a decimal out of place somewhere. Okay? So go back and look and see if there's a mistake you can identify. If you know you have a mistake and you can't find it, then leave your work so Ms. Felice or I can look at it and try and give you credit for what part you did right. Okay? So don't just erase it in frustration and go, I've got this totally wrong. You probably have got part of the idea right. You maybe have some basic proficiency. So I got 32.20, and I knew the label was AMU because my percents cancel out, and my mass was given in AMU. Mass will generally be given in AMU or in grams. In this case, it's AMU, so that's what I label. And when I look, 30.97 is phosphorus, 32.07 is sulfur, and 35.45 is chlorine, so it's closest to sulfur. So why isn't it exactly the same? Because equipment always has some uncertainty in it. Equipment's not 100% perfect. So that's the closest element to it. Get this